All right, so you know how sometimes you glance at your Proxmox server and you see that memory usage just creeping up there?
Oh, yeah.
It can be kind of freaky, right? Especially if you're running ZFS.
Definitely, yeah.
You
I've
know,
seen people get really anxious about it.
but before you hit that panic button, let's take a deep dive into what's really going on with memory in Proxmox, and particularly with ZFS.
Yeah, it's funny how we tend to see high memory usage as like a bad thing automatically.
Right.
But when it comes to ZFS, it can actually be a sign that things are working really well.
Oh, interesting. So maybe it's not so much a problem, but more like a quirk of how ZFS operates.
Exactly. It's all about how ZFS leverages memory for performance.
So to really get this, we need to start with ZFS itself. Can you give us like a quick rundown of what makes ZFS so special in the first place?
Sure, ZFS, it's this combined file system and volume manager, and it's known for its rock-solid data integrity and its performance.
So it's like having a super organized filing system that's also constantly backing things up and can even rebuild itself if something goes wrong.
Yeah, that's a great way to put it. And a big part of that performance comes from this thing called the adaptive replacement cache, or AR. And this is where things get a little memory hungry.
Ah, so the ARC is like the FS's secret weapon for speed.
You got it. The ARC lives in your server's RAM, and it keeps all the frequently accessed data readily available.
Okay.
So ZFS doesn't have to go digging through those slower hard drives every time it needs something.
So it's like having a chef who keeps all the most used ingredients right there on the counter instead of running back and forth to the pantry every 2 seconds.
Perfect analogy.
Uh-huh.
But counter space is limited, right? So how does ZFS balance this need for speed with the reality of having finite RAM?
Right.
Well, that's where the adaptive part of RSC comes in. It's constantly analyzing how you're using data and adjusting its size accordingly. So if other applications need memory, it shrinks down. If there's plenty of free RAM, it'll expand to take advantage.
So it's like a self-adjusting pantry that grows or shrinks based on what you're cooking.
I like it. And this is where things can get a little confusing. You might see ZFS using a ton of RAM, like even 90% or more, and understandably, you might freak out a bit.
Oh yeah, I've been there.
Right, you start thinking, is my server about to crash?
It's something terribly wrong.
But here's the key thing. Not all used memory is created equal. That memory allocated to the ARC isn't necessarily being actively used at any given moment.
Yeah.
It's more like reserve space that ZFS can tap into when it needs to, but it can also release it really quickly if other applications need it.
So it's kind of like having a guest room that's always ready, but it doesn't mean you have a permanent house guest.
Exactly. ZFS is just being proactive, making sure it has the resources available for that top-notch performance.
Okay, that makes me feel a bit better. But how do we figure out what our memory numbers actually mean? Like, how do we separate that reserved memory from the active memory?
One of the simplest ways is using the free command in Linux. Specifically, freeAH gives you a nice breakdown of your memory usage. Let's walk through an example. Imagine you run freeH and you see this output.
Yeah.
Total used free shared buff cache available.
15G, 13G, 617 MI, 241 MA, 1.7 GI, 2.1 GI.
7.6 GU, 0B, 7.6 GA. So what do we see here?
Yeah.
The used memory line, that 13 GB, and includes both memory actively used by applications and memory allocated to caches like that ZFS ARC.
Okay, so that 13 GB number might include a good chunk of that reserved memory
Right.
that ZFS is holding on to.
Right, exactly. The buff cache line is the memory dedicated to temporary storage. But the most important thing to look at is the available memory.
Gotcha.
In this example, it's showing 2.1 GB.
So available memory gives us the real picture of how much memory is truly free or can be easily reclaimed.
You got it. So even if that used memory number seems high, you might still have plenty of available memory thanks to the magic of caching.
All right. I'm starting to feel much less stressed about those big memory numbers. But what if I actually want to put some limits on how much RAM ZFS can use for its ARC? Like, maybe I'm running a bunch of virtual machines on my Proxmox server and I want to make sure they have enough resources. Is that something I can control?
Absolutely. We'll dive into how you can fine-tune the ARC's memory usage in the next part. Stay tuned.
All right, so we've learned that the ARC can be a bit of a memory hog, but it's not necessarily a bad thing.
Right.
But let's say we do want to put some boundaries on it.
Yeah.
How do we actually set limits on how much RAM the ARC can use?
Well, you're going to be working with the ZFS configuration file.
Okay.
Usually it's located at setcmodprobe.dzfs.conf or at ccsc.sems.com.
Okay.
If it's not there, you can just create it.
All right, so we find the file or create one if it's missing. What's the next step?
You're going to add a line to that file
Okay.
to set the maximum ARC size. And it'll look something like this: option ZFS ARC Max 85899345592.
Okay, whoa, that's a pretty big number. What's going on there?
So that's 8 gigabytes in bytes.
Oh.
So basically this line tells ZFS, hey, you can't use more than 8 gigabytes of RAM for your RC no matter how much you want to.
All right.
You can obviously adjust that value based on, how much RAM your system has and what your other applications need.
So if I have like a 16 GB system and I want to make sure other processes have at least half of that available, I could set that ZFS ARC Max to 8 GB.
Yeah, exactly.
Yeah.
It's all about finding that sweet spot between ZFS performance and, keeping your other applications happy.
Okay, so we've added that line to the configuration file. What's next? Do we just reboot the server?
You can either reboot, or if you want to do a quicker update, you can reload the ZFS module.
Okay.
And you can do that by running sudo modprobe ZFS
All right, I'm starting to feel like a ZFS expert here.
Ha, good.
But we've been talking a lot about ZFS. Are there other things that can cause high memory usage on a Proxmox server?
Yeah, absolutely. ZFS and its ARC are just one piece of the puzzle.
Right.
Even without ZFS, you might see high memory usage, and there's a few reasons for that.
Yeah. Okay.
One common one is overprovisioning RAM.
Overprovisioning. What does that mean?
It means you've given your VMs or containers more RAM than your Proxmox server actually has.
So like if I have a server with 16 GBs of RAM and I give one VM 8 GB and another VM 10 GB, I'm in trouble.
Yeah, exactly.
Yeah.
In that case, you've overcommitted your RAM,
Yeah.
and then the system might have to start using swap space, which is like an overflow area on your hard drive.
Okay.
And it's much slower than RAM, so you'll get performance issues.
So it's like having a party and then asking some guests to hang out in the garage because there's no more room in the house.
Yeah, that's a good way to put it, except the garage in this case is your hard drive, which is a lot slower.
Right.
So you want to be careful about over-provisioning.
Okay, so don't be too greedy with the RAM allocations.
Exactly.
How about those memory leaks I've heard about? Are those something to worry about in Proxmox?
Yeah, memory leaks can definitely happen on any operating system, even on Proxmox.
Why?
And it's basically when a program doesn't release memory, it's not using anymore. So it's like leaving a faucet dripping. Those little drips can add up over time.
So how do we prevent those memory leaks from happening? Is it just like closing programs when we're done with them?
Well, sometimes it's more complicated than that.
Okay.
Memory leaks often happen because of bugs in software or outdated drivers.
Okay.
One of the best things you can do is keep your software updated.
Right.
Developers are always patching these things and releasing new versions.
So it's like making sure your car gets regular maintenance to keep it running smoothly.
Exactly.
Now, we've talked about using free agents to see how much memory we're using. Are there any other tools we can use to find out what's using up all our memory?
Oh, yeah. There are some really great tools out there.
Okay.
One of my favorites is HTOP.
Yeah.
It gives you this live view of all the processes running on your system and how much memory they're using.
I've used HTOP before. It's really helpful for getting a quick overview.
Yeah, it's really easy to use.
What other tools would you recommend?
Another good one is a top, and it's specifically focused on system performance.
Right.
So you can see things like CPU usage, memory usage, disk activity,
Okay.
and gives you a lot more detail than HTOP.
So HTOP for a quick look and then a top if you want to dig deeper.
Exactly.
Sounds good. What about if you want to get really fancy? Go beyond those basic tools.
Well, if you're comfortable with the command line and you like to write scripts,
Yeah.
you can create your own custom scripts for analyzing memory usage.
Cool.
And you can really tailor them to your specific needs.
Right.
So there's really no limit to how deep you can go.
So it seems like understanding memory usage isn't just about fixing problems.
No.
It's about getting a better understanding of how your system works.
Exactly. You can make better decisions about how you allocate resources and optimize your system.
Okay, so it's about being proactive and making sure your Proxmox server is running at its best.
Absolutely.
All right, welcome back to the deep dive. So we've gone through ZFS, the ARC, other memory hogs, and some tools for figuring out what's using all that memory.
Right.
But now let's talk about how we can actually make our Proxmox servers run better.
Yeah, optimization. Let's get into it.
All right, so where do we start? What are the key things we should focus on when it comes to memory?
One of the first things I look at is how memory is allocated to virtual machines.
Okay, so those VMs.
Right. We talked about over-provisioning before.
Yeah, don't be too greedy.
Yeah, exactly. You want to find that balance between giving your VMs enough RAM and making sure you don't overcommit.
Right. How do we find that sweet spot?
Well, one thing that can really help is dynamic memory allocation.
Okay, I've heard of that. What is it exactly?
Basically, you set a minimum and a maximum amount of RAM for each VM.
Right.
So it starts with the minimum, and then it can request more from the host if it needs it up to that maximum.
So it's like giving the VM a credit card with a limit.
Yeah, exactly. That's a great way to put it.
Oh,
So you get that flexibility, but you're also making sure that one VM doesn't just hog all the memory and leave the others with nothing.
right. Makes
Yeah.
sense.
Yeah.
So that's dynamic memory allocation. What else?
Another thing to think about, especially if you're running applications that work with large data sets, is huge pages.
Huge pages.
Okay.
So modern CPUs, they manage memory by dividing it into these small pages.
Okay.
But if you have an application that's dealing with a ton of data, all that paging back and forth can really slow things down.
So it's like trying to read a giant book one tiny sentence at a time.
Yeah, exactly. It's not very efficient.
Right.
So huge pages let the CPU access larger chunks of memory at once.
So less flipping back and forth.
Exactly, and that can really boost performance.
Is that something we need to set up ourselves, or does Proxmox handle it automatically?
You'll need to enable it in both Proxmox host and the guest VMs.
Okay, so a little bit more involved, but worth it for those performance gains.
Right. And one last tip for people running I/O-intensive applications on ZFS.
Okay.
Think about using a dedicated SSD for ZFS metadata.
Now, when we say metadata, we're talking about like information about the data itself, right?
Yeah.
File names and dates and permissions and things like that. Exactly. It's like the index that ZFS uses to keep track of everything.
Okay.
And by putting that metadata on a fast SSD, you can really speed up those metadata operations.
So it's like having a separate express lane just for all those background tasks that ZFS needs to do.
You got it. And that can make a big difference for applications that need quick access to all that file information.
Okay, so we've covered a lot of ground here. ZFS, the ARC, other things that can use up memory tools for analyzing it all, and now even ways to optimize it.
Yeah.
What are the key things our listeners should take away from all this?
I think the most important thing is to remember that high memory usage isn't always a problem.
Right.
Especially with ZFS, it often means things are working as they should.
So don't freak out if you see a big number. Just take a deep breath and figure out what's really going on.
Right. Use those tools we talked about and then decide if you actually need to optimize anything.
And even if you do decide to change something, always test it out and see how it affects your system.
Exactly, because every system is different.
All right, so be informed, be careful, and don't be afraid to experiment a little.
Absolutely. The more you know about how memory works in Proxmox, the better you'll be at managing your servers.
And that's what it's all about, keeping those servers running smoothly.
Definitely.
Well, I think that about wraps up our deep dive into memory management in Proxmox. Thanks for joining us.
It's been a pleasure.
We hope you found this helpful and maybe even learned a thing or two.
I hope so.
Keep exploring, keep learning, and until next time, keep those Proxmox servers humming.